So hello everyone. I hope you're having a good day so far.
Yeah.
Today we are going to discuss about what happens if a cow weighs 350 kilograms eats 10 kg of biuret. So before we start the whole discussion, let's start with you. Introduce yourself.
Hi, I'm Dong Shen. My match number is 181588.
My name is Tushan Alushan, mattress number 181290.
My name is Siti Suhaila binti Muhammad Ma'ruf. Ticket number 181636.
My name is Putri Sabrina with the matrix number of 182201.
I'm A. Injan with the metric number of 183825.
My name is Amir Abdurrahman bin Manafi, metric number 18208.
Okay, so before we proceed, I would like to define biuret. So biuret is a chemical compound with the chemical formula of C2H5 and 3O2. It is also known as carbomuria. It is the result of condensation of two molecules of urea and is a problematic impurity in urea-based fertilizer. So here are the objectives of this discussion. First, we want to investigate why 9-protein nitrogen, also known as NPN, is added to a cow's diet. And second, we would like to study the composition of urea and biuret. And third, to study the nitrogen metabolism and microbial production if dairy cells are fed with NPN. Fourth, to describe the urea cycle. And lastly, to study the effects of overconsumption of biuret. So there are also two important terms to know here. First is triuret, which is an organic compound with a formula which has a very complex formula. It is a product from the pyrolysis of urea. And the second term is microflora. We'll be encountering that when we discuss later, which is the community of microorganisms, including algae, fungi, and bacteria that live in or on another living organism or in a particular habitat. Okay, so I would like to start off the discussion with why do people add 9-protein nitrogen into the diet of a cow? Okay, first, protein is often the major limiting nutrient for ruminants. Protein-rich leguminous forages they rarely give it to cows in farms because it's very expensive. Even the vegetative supplements are rarely given because of the cost. Because we Malaysians are all about, minimizing the cost because everything is increasing right now. So the manufacture of urea and ammonia for use as fertilizer has been greatly expanded in many countries, including Malaysia. But these compounds could be used more widely in feeds for ruminants. And it is also important to know that protein is not as important in ruminants as compared to non-ruminants, so they don't need that much protein, which could be an irony there. And the ability of the microorganism in the rumen of cattle and sheep to utilize these NPN sources to form true protein that can be converted to meat and milk by the animals represents an important contribution to man's food supply. What this means is that when we give too much of urea and biuret to the diet of a cow, it can actually affect the taste of the meat and the milk itself, because it will, of course, whatever that we eat will actually form in our meat. Yeah. So that's why we should provide healthy food and supplements for all animals, and we need that for ourselves as well. So it can be calculated that pure urea contains 47% of nitrogen compound compared to 16% for most proteins, which means that urea has more nitrogen compound that can be converted by the microorganisms in the rumen as compared to protein itself, which is what people prefer urea more than protein. And research has shown that the biological value of proteins is much less variable for ruminants than for ruminants. Rumen microorganisms synthesize protein from substances containing nitrogen to build up their cells, and ruminants use this aspect of the microorganism to satisfy and sometimes all of their need for protein from non-protein nitrogen compounds. So I can say that first, people prefer the usage of urea over protein because it's much cheaper and it contains more nitrogen compounds that can be converted by the microorganisms in the rumen. So, what do you guys think about that? But if you were to have your own farm, would you provide like the perfect diet for the cow? But then it requires you a lot of money, or would you want to use urea instead of protein? What would you do?
I think we will use urea.
Yeah. Yeah, because some people really care about the intake of the cow because they want to produce really good quality meat. What about you?
I already choose protein because as a vet, we're
Yes.
practicing animal welfare. So since we're feeding it too much protein, it's not good for the animal. So that's bad animal welfare.
Oh.
Yeah. Even though have to spend more
Yeah.
for the feed, but in the future will benefit to ourselves
Yeah.
because we reduce the medication cost for the cattle and
Yeah.
and reduce loss of beef.
Yeah. And milk as well.
Yeah.
What about you?
For me, it will depend on my financial state at that time. For starter, maybe I don't have money yet, so I will use urea first. And then if I'm in
More money in the
money,
future.
I will use first.
You know what I mean?
Maybe we can use a mixture of like both urea and
yeah,
purified
that's
food.
It's
We
more
can also
like
provide purified milk and also
Yeah.
save a bit. Yeah. It all depends on why you want to keep it.
yeah.
For me, I would choose the urea because what the farmers and the farm management, what they concern is the cost in the production.
Yeah, that's true.
But if you have cattle in a large quantity, it's quite impossible for you to produce high cost.
Yeah.
That's true.
Because like if we use the urea and the adequate amount can actually cost more harm to the cattle.
Yeah, that's true. I agree with that too. So could you
Okay, I would like to
continue?
continue then. I will explain about the conclusion of biuret. Biuret is a food for the use in nutrition of cows, typically in daily lactation diets. Biuret is formed by the controlled decomposition of urea, condensing two molecules of urea into a single molecule of urea, which retains three of the nitrogen atoms. Free-grain biuret is a mixture containing biuret and urea, maximum of 14%, with a small amount of biuret and diurnuric acid. Typically, biuret contains a minimum of 35% of nitrogen with a crude protein value of 246%. Biuret is less soluble in urea. Biuret is less soluble than urea as the composition of its structural and physical characteristics shows the Roman tradition of urea. The slower degradation and physical properties assist in forming high quality self-fed supplement. Biuret is at least 7.3 times less toxic than urea. So biuret is less toxic than urea, so better use biuret than direct urea. That's why it's recommended for cows.
So does biuret have lower nitrogen content than urea?
Yeah.
Oh,
And it has been made in such a way like for it not to be toxic for the cow. It is a feed actually for the cow.
oh.
Even if it's made from urea, but it's not.
So is it genetically engineered? Like, can it be obtained from like a specific source, or they have to alter the composition of urea?
No, I
and
think
make-
they
Some kind of improved feed.
in the laboratory they should work on it. Because we don't really produce urea, we don't produce urea. Even all numbers produce urea, they do it.
Oh
We
yeah.
have to improve that. So I have said biuret is at least 7.3 times less toxic than urea, making it ideal when using higher levels of NPN and in self-fed applications. Biuret can be substituted for true protein and will provide metabolized protein available to the animal. Compositions of biuret and urea will likely be desired to maximize NPN in diets to reduce protein counts when faced with combination of sugar, finely ground H and C, and the more rapidly fermented processed corn silage. There's no question but that urea and certain other non-protein nitrogen substances can be fed directly to ruminants to replace part of their dietary vegetable protein. Favorable results can be expected when cereal grains are also included in the ration, but performance may be less satisfactory on forage alone. That is, we put the urea, we add also some cereal grains to make it better. If you use forage only, you will have the result, but it will average. Urea may cause toxicity, as I said earlier, and even death in ruminants if it is fed inadequately, mixed with other feed, or in too large a dose. The toxic signs can be easily recognized. Okay?
So there are symptoms.
Yeah.
Yeah.
Okay, since Toshan has already introduced you about the composition of urea, I'll talk about the composition of urea. So urea or carbamide is an organic compound and serves an important role in the metabolism of nitrogen-containing compound by animals, and is the main nitrogen-containing substance in the urine of animals. It is a colorless and odorless solid, highly soluble in water, and partially non-toxic. The material occurs not only in the urine of all mammals but also in their blood, bowel, milk, and perspiration. Urea is in the class of feed nutrients and called the nitrogen protein, non-protein nitrogen. This classification of nutrients, along with the excess protein and highly human degradable proteins and their derivatives, are converted to ammonia in the rumen and supply a source of nitrogen to the rumen microflora. Urea can be added to a point where this pool of nitrogen for microbial use is satisfied. So further additions will lead to diet energy loss because of excretion or ammonia toxicity. About 35 grams of urea per day is considered sufficient for a 400 kg of cow, which means that it's approximately 0.1 gram per kg of the body weight of the cow. And it's recommended that urea should provide not more than 3% of the concentration ration or 1% of the total feed intake, and no more than one-third of the total nitrogen intake should be NPM. So in cattle, 0.2 to 0.5 grams per kg per day, for example, 120 to 200 grams for a 400 kg cow, is considered to be toxic, and 1 to 1.5 grams per kg per day, which is example 400 to 600 grams for a 400 kg of cow, can be fatal.
Sorry, how much is it now? Which is too much for the cattle.
What can be fatal?
The amount of protein. Or is it urea?
In cattle, it's 0.3 to 0.5 grams per kg per day. Yeah.
There is too many.
Yeah, can cause fatal.
So keep use of that.
Yeah.
Keep it that.
Yeah. Okay, so next question.
Who can explain a bit about the urea cycle?
Actually, I can. Yeah, as you all have mentioned about the urea is the chief nitrogenous waste of the mammals, which including us as the human. And most of our nitrogenous waste come from the breakdown of amino acids from the diet we consume. And this process occurs by deamination, which is the removal of the amino group from the amino acid. And the deamination of the amino group will result in the production of ammonia. Ammonia is extremely toxic waste, and its accumulation to our body can be fatal, which can cause death to us. But we don't need to worry about it, as we got the liver, which contains a system of carrier molecules and enzymes, which will really convert the ammonia into urea through a process that called urea cycle. Urea cycle actually involves 5 steps of reaction, and 1/3 of the cycle will consume 2 molecules of ammonia and 1 molecule of carbon dioxide, resulting in 1 molecule of urea, and we generate a molecule of ornithine to be used in the next cycle. Although our body cannot tolerate high concentration of urea, but the urea is actually less poisonous than the ammonia. However, urea still needs to be removed efficiently by our kidney through the excretion of the urine, and the excess amino acids are channeled into a single secondary end product. Terrestrial animals such as cows, they will excrete urea and are called urea-chloric animals. And in this kind of organism, the excess ammonia is channeled to the mitochondria of urea cells and are converted into carbamoyl phosphate catalyzed by the carbamoyl phosphate synthase enzyme, and this substrate will enter into the nitrogen as the urea cycle. The urea cycle is also known as the other name called ornithine cycle. And it's cycle of biochemical reactions that occur in many animals that produce urea from ammonia. The urea produced in the liver will then release into the bloodstream, and after that, when the urea reaches the kidney, it will be filtered out into the urine and will be excreted out of the body. So, like, does anyone have further explanation about the more detail of the urea cycle?
Well, as you have said, urea cycle consists of four reactions. I will explain about the four reactions now. The first reaction in the urea cycle begins in the mitochondrial matrix. Ammonia is produced in the mitochondrial matrix by the enzymatic activities of glutamine and glutamate dehydrogenase. Carbamoyl phosphate synthase 1 is the enzyme that takes the ammonia bicarbonate and 2 molecules of ATP to produce carbamoyl phosphate. This enzyme activates bicarbonate by the same method used by biotin containing enzymes. In fact, carbamoyl phosphate synthase is homologous to the biotin family of enzymes. Carbamoyl phosphate synthase 1 activates bicarbonate by phosphorylation with ATP to form carboxyphosphate. So this is where ATP is used, and then ammonia then reacts with carboxyphosphate to form a carbamate intermediate. A certain molecule of ATP, another molecule ATP is used to phosphorylate the carbamate intermediate to form carbamoyl phosphate. Carbamoyl phosphate synthase 1 is the first conjugate step of the urea cycle. This enzyme is allosterically activated by N-acetylglutamate. N-acetylglutamate is a precursor for ornithine biosynthesis and is an essential activator for the urea cycle. N-acetylglutamate also serves to coordinate related pathways. There is a citrulline transporter that transports citrulline from the matrix of the mitochondria to the cytosol. There is also an ornithine transporter that transports ornithine from the cytosol into the matrix of the mitochondria. The rest of the reactions of the urea cycle occur in the cytosol. So before it is in matrix of mitochondria, now we move to the cytosol. The next step of the urea cycle is catalyzed by argininosuccinate synthase. This enzyme uses ATP to activate citrulline by forming a citrulline AMP intermediate. In the second half of the argininosuccinate synthase reaction, the alpha amino group of aspartate attacks the aminocarbon releasing AMP and produces argininosuccinate. So the third step of the urea cycle is catalyzed by argininosuccinate lyase, which catalyzes the reaction shown, which is the product of these reactions are arginine and fumarate. The fumarate product is an important link between the urea cycle and the citric acid cycle. So these are two of the cycle related. The last reaction of the urea cycle is catalyzed by arginase, which catalyzes the hydrolysis of guanidino group to produce urea and ornithine. Ornithine is then transported back in the matrix of the mitochondria and the cycle will be complete. The synthesis of urea in the liver in the primary route of removing excess ammonia. A deficiency in any of the enzyme of the urea cycle has devastating consequences. Deficiencies in the activities of the enzymes of the urea cycle will lead to hyperammonemia. Genetic defects are manifested in hyperammonemia days after birth. The infant will become lethargic and vomit periodically. Coma and brain death soon will follow. A high concentration of ammonia in the infant's brain leads to brain swelling. Strategies have been developed to overcome the enzyme deficiency. So that's from the human way. Does it have this effect on the cow before? I think because if you take the cycle in the enzyme makes it
Wow, it's such a
very
I
complex.
know. I think
Only
you go back and
one.
read our
And that's only for amino acid.
Yeah.
The brain is like
Yeah.
Okay, so like you just have sound, but then the effects for cows. Basically, overconsumption of urea will lead to urea and ammonia toxicity, and then eventually death. That's it. And if let's say from the topic it says that 10 kilos of urea, right? So here it mentioned that 100 gram of urea will be equal to 220 gram of digestible food protein. So let's say if 10 kilos of urea, it is equal to 22 kilos of protein per day. So it's exceeded by like almost 20 times the maximum protein per day. So yeah, so like for this condition it's like 100% that because because the treatment is really effective in any situation because the symptoms are really hard to detect. Okay, a normal level of urea in human liquid is 60 over 680 milligram per liter and 0.8 to 2.5 milligram per liter in that. Urea poisoning is one of the more commonly suspected toxicities of cattle in the top end in the major industries because, like mentioned before, it reduces costs for the production of the cattle. So and it's often to know that a cow died from urea toxicity if it found them dead close to the source of supplement, which is the urea. Yeah. Like mentioned by Racing and Swiler just now with the urea metabolism, right? Because the main purpose is to convert ammonia to urea, right? But if
Ammonia is not converted.
yeah, because of the cattle just say 10 kilos of urea, so it's already overwhelming the excretion system. So there are not enough enzymes to convert from ammonia to urea, so it accumulated in blood and that caused ammonia toxicity and
So they die right after they eat.
no, like I said just now, there's symptoms, but the symptoms are difficult to notice because some of the symptoms includes twitching of ears because
I find it normal.
it's normal.
Yeah,
Yeah, facial twitching of ears and facial muscles, grinding of teeth, frothy salivation, bloat, abdominal pain, and frequent urination or forced rapid breathing. As we can see, the symptoms is generally when a cow is stressed. So a cow easily gets stressed in any condition that
Do they show that symptoms also for other diseases or like specifically a different way of showing that they're stressed?
I'm not sure about that, but let's say if you get a disease and you must be stressed about it. Yeah, so maybe it's the same. Yeah, but one that is different is the bloat. Yeah, but even this is hard to notice because once they start bloating, they just die. That's the last symptoms of it. So, the treatment is, like I said just now, it's really effective. But however, cattle can be handled by stomach tubing to pass the relief of bloat, and then use drenching the animal with large volume of water, which is for about 45 liters for an adult cow, followed by 2 to 6 liters. Yeah, it's 45 liters. Followed by 2 to 6 liters of 5% acetic acid or vinegar. This will dilute the rumen content, reduces rumen temperature, and increases the rumen acidity, which all help to slow down the production of ammonia. Treatment may need to be repeated within 24 hours, as relapses can occur. Ruminectomy and removal of rumen contents is suggested for valuable animals. Like, for example, if you kept the animal as pets, and this is highly suggested. But if it's a livestock animal, just call it. That's it. Yeah.
I think almost we choose to call it because it takes a lot to take.
Yeah, it even um, fermenting the
Yeah, I
cattle
know.
inside. Because the treatment itself is hurting the
Yeah, I would like to know why should we use cold water to treat that specific disease?
like I said just now, it reduces the room temperature, so and also increase the contraction of the muscle of the cattle so that allow more gas to come out.
Also, we have to do it like only internally, not externally. Like you know how buffalo they tend to pick up the mud and throw it back to their body to pull themselves down, to prevent,
The process for buffalo is like a slow process. It's a slow cooling process. That's why buffalo
Take a long time.
take a lot.
Like
Take a lot.
cattle don't do that, right?
Yeah,
Yeah.
because don't do that. And because during this time the temperature already increases a lot, so it's better to drench than cold water. Yeah.
How is drenching being done?
Just forcing.
Forcing the liquid.
Yeah.
Oh.
45 degrees.
Oh my
Yeah,
god.
so does the 45 liters, 45 liters of water like giving at once or like
Little by little, but finish it in one go. Yeah.
Would that cause bloating? Like, what do you think? Would it? Yeah, in your opinion? Because for us humans, when we drink too much water, we like to bloat.
I think it will bloat and we'll do it sometimes to cut it out.
Yeah.
Urinate it out.
Or maybe because the
What?
pressure from the water it forces the gas to go out by itself. Yeah.
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 The water replaces it.
Yeah.
So does anyone have any other thing to add on?
I can tell about the ideal diet of the cow.
Actually, it was a brief.
So dairy cows are produced milk. They require a lot of energy. So just like you and I, cows eat a mixture of different kinds of food to maintain a well-balanced diet. Cows eat a mixture of grass, hay, alfalfa, hay, grains, as well as coarse and grass range. Grass and alfalfa are dry to make hay. Farmers grow a lot of grass and corn at their farm. Having dry hay ensures that the cow will have food all year round, so hay can store it. Even if there's a period of flood or drought, the hay can be used for the aspect of the cow. Grain or a mixture of corn, oat, barley, as well as added minerals and vitamins. Farmers will add an extra mineral and vitamin in their feed to make sure their cow are healthy and growing strong. Cows also eat alfalfa and grass silage, as I said earlier. Silage is fermented to give it extra nutrients. Farmers use all parts of the corn, including the husk and cob, to make corn silage. While hay is dry, silage is moist. Hay is dry, silage is moist. Yeah. Farmers work with animal nutritionists to make sure that their cows are given a healthy and nutritious diet. Each farm will have a special formula of food developed by the animal nutritionist. The average dairy farm in Malaysia have around 120 milking cows. And on average, a cow eats 100 pounds of food every day. So it's like around 50 kilograms.
So long.
A day.
Yeah. So what's the weight?
Huh?
What's the weight?
64.
Anyone got the weight?
No.
Okay.
So they actually eat a lot of food. So we should supply them the food. To ensure that the dairy cows are not picking fruit, their food, farmers mix all 5 of these fats into a TMO. TMO is total mixed ration. We use this in the goal that every bite of food a cow takes will have exactly the same amount of nutrients. So we use the total mixed ration such that every cow has the same, like everything they eat, like it's almost the same compared to the cow next to him. Because the cow same value fat.
Can cows be picky? Animals are quite picky what they want to eat. Like,
Yeah, maybe because if you feed only like 100% hay or dry grass, they will eat but not much. But whereas if you mix it well with the silage, with more
Yeah, just like we won't eat the rice.
Yeah. And the farmers prefer to use that to total expression so that all cows get the same amount of nutrition, then the output of milk is also the same. Yeah. I think that's all for me. Anyone would like to go there?
no. Okay, so that's all for our discussion. That was a great discussion.
Yeah.
So, yeah.
Thank you,
Thank
everyone.
you.
Bye.
Bye.
Bye.